In this problem, this means leading coefficient is 1. And this means cubic function. So you can make the equation f of x equal to x cubed plus ax squared plus bx and constant. And this box means the integer k does not satisfy this inequality. So integer k satisfying this inequality, this means does not exist. And there is some information about derivative. So f prime of minus 1/4 is minus 1/4, and f prime of 1/4 is negative. And when there is a negative derivative in a cubic function, when the leading coefficient is positive, this graph satisfies the decreasing interval. So in this case, when x is minus 1/4, the slope is negative. And when x value is 1/4, still negative. And because 0 is located between minus 1/4 and positive 1/4, this means when you think of the derivative, f prime of 0 is still negative. And we can think of 5 cases when this graph has the interaction with the x-axis. So the first case is x-axis is below the local mean. The second case is the local mean is the x-intercept. The third case is x-axis is located between local max and local mean. And the fourth case is local max is the x-intercept. And the last case is x-axis is above the local max. And for the first two cases, when x is 0, f of 0 is positive. And in this case, when the negative root is greater than or equal to negative 1, in such case, negative 1 satisfies this inequality. Because negative 2, f of negative 2 is negative, but f of 0 is positive. So minus 1, integer minus 1 satisfies this inequality, and that's not the case we want. Or let's say the negative root is located between negative 2 and negative 3. In this case, now negative 2 is the integer satisfying this inequality. So this means when f of 0 is positive, and there will be a negative integer satisfying this inequality. So the first two cases are not what we want. Conversely, when f of 0 is negative, and when the positive root is greater than or equal to 1 but less than 2, in such case, 1 is the integer satisfying this inequality because f of 2 is positive and f of 0 is negative. When the signs are opposite, the product is less than 0. Or when the positive root is greater than or equal to 2 and less than 3, now 2, integer 2, satisfy this inequality because f of 1 is negative and f of 3 is positive. So when f of 0 is negative, there will be one positive integer satisfying this inequality. So this means f of 0 cannot be positive or negative. So the only position for f of 0 is 0. So we can think of this graph when the x-intercept is 0. And in this case, once again, if the positive root is greater than 1 but less than or equal to 2, two is the integer satisfying this inequality because f of 3 is positive and f1 is negative. And if the positive root is greater than 2 or less than or equal to 3, and now number 3 is the integer satisfying this inequality. So that means this positive root should be less than or equal to 1. And likewise, the negative root, when negative root tries to be less than negative 1, there should be a negative integer satisfying this inequality. So that means the two roots, positive and negative, they should be located within the interval from -1 to +1 inclusive. So one case we can think of is when all of the roots are integers, 0, -1, and 1. In this case, we can directly find the equation of the function. And if we make the differentiation, f prime of -1/4 is not -1/4, and because of this confinement, this case is not what we want. So if we try to make the positive and negative root not integer, 이렇게 like this. Now the problem is, because f of 1 is positive and f of minus 1 is negative, this integer 0. Integer 0 satisfies this inequality. So this is also not the case we want. So that means one of the roots should be an integer, and then the other root should be less than the integer. So the first case is, let's say negative root is minus 1 and positive root is located between 0 and 1. In this case, we can make the equation of the function this way, and if we open the parentheses, and then make the differentiation. And in this case, f prime of minus 1/4 is equal to minus 1/4. So let's multiply 16 to both sides. In this case, value of alpha is minus 1/8, and because alpha should be a positive number, this is not the case we want. So the last case remaining is when the positive root is 1 and the negative root is between minus 1 and 0. And then let's say the negative root is beta, and if we make the equation, and once again, after opening parentheses, we can make the differentiation. And in this case, f prime of a negative 1/4 is minus 1/4. So once again, let's multiply 16 to both sides. And so this makes beta equal to minus 5/8, and this satisfies the location of beta between minus 1 and 0. So now we finally find out the equation for this function. And the answer we want to find is f of 8. So when x is 8, 8 times 7 times 69 over 8, so we can cancel 8. So 7 times 69 is 483 is the answer. So that's it for this video, and thanks for watching.